This program is rated SPG. It contains scenes with themes, language, violence, sex, horror, or drugs, which may not be suitable for children. Strong parental guidance is advised.
Good afternoon, ladies and gentlemen. Handa na ba kayo?
Handa na kami!
Good afternoon po to both of you.
Good afternoon to Sir Rafi.
So based on what you provided me, you are complaining about Lawrence and Ronnie about oxidation phosphorylation because they didn't teach the topic.
Yes, sir. Now, they wanted us to take an exam about the topic. That's illegal.
That's why we reported them to you, Sir Tulfo.
Okay. Alright, since that's the case, I have personally invited them to the studio. So all you can talk. And so I can help both parties in make this.
So po, Idol Rafi.
Good afternoon po. I'm sure you two are aware why you hired me. Okay, what really is oxidation? Phosphorylation.
Well, it is essentially the step in the cellular respiration. It occurs that the mitochondria are linked to a process known as the electron transport chain.
Sir, the electron transport system is located in the inner mitochondrial membrane. The electrons are transferred from one membrane of the transport chain to another through a series of redox reactions.
Why only now you're telling us this?
Only when we reported you to Sir Idol Rafi Tulfo.
You were supposed to self-study this topic. You're a STEM student anyway, right? Why you can't learn it yourself?
Yes, and we teachers can just give you the topics to study.
Okay, wait, stop. We shouldn't fight over something as this. Anyway, continue about oxidation phosphorylation.
Sir Tulfo, energy released in this reaction is captured as a proton gradient, which is used to make an ATP process called chemiomosis. Together, the electron transport chain and chemiomosis make up oxidative phosphorylation.
Yes, the key steps of this process is simplified form. Includes the delivery of electrons carried by the NADPH and FADPH. Electrons transfer and proton pumping, splitting oxygen to form water, and gradient-driven synthesis of ATP.
Okay, but can you further explain the electron transport system?
Yes, sir.
Your explanation is not even complete.
True, why can't you just say it properly?
You're not letting us finish. Anyway, the electron transport chain is a collective membrane-embedded proteins of organic molecules. Most of them organized into four large complexes, labeled 1 to 4. In eukaryotes, many of copies of these molecules are found in the inner mitochondria membrane. In prokaryotes, the electron transport chain components are found in the plasma membrane.
As the electrons travel through the chain, they go from the higher to lower energy level, moving from less electrons hungry to more electron-hungry molecules. Energy is released in this downhill. Electrons transfers and several of protein complexes use the released energy to pump protons from the mitochondrial matrix to the intermembrane space, forming a proton gradient.
Meaning, all of the electrons that enter the transport chain come from NADH and FADH molecules produced during earliest stages of cellular respiration, glycolysis, pyruvate oxidation, and the citric acid cycle. What do you think, Ronnie and Spear?
NADH is very good at donating electrons in redox reaction, so it can transfer its electrons directly to complex 1, turning back into NADH+.
FADH2 is not as good as donating electrons as NHDH, so it cannot transfer its electrons to complex 1.
Then,
Overall, the electron transport chain has two important functions: regenerate electrons carriers and make more gradients.
okay, well, let's move on. You mentioned another term before, chemiomosis.
Yes.
What is that?
Again, Idol Rafi needed to point out another
Complexes
term
1, 3,
because
and
you
4
two are
of the electron
incompetent.
transport chain are proton pumps as electron moves energetically downhill. The complexes capture the released energy and use it to pump H+ ions from the matrix to the intermembrane space. This pumping forms an electrochemical gradient across the inner mitochondrial membrane. The gradient is sometimes called the proton motive force. And you can think of it as a form of stored energy, kind of like a battery.
Like many other ions, protons can pass through directly the phospholipid barriers of the membrane because its core is too hydrophobic. Instead, H plus ions can move down through the concentration gradient only with the help of the channel proteins that form hydrophobic tunnels across the membrane.
Based on what little things you taught us, in the inner mitochondrial membrane, H plus ions have just one channel available, a membrane-spanning protein known as ATP synthase. Conceptually, ATP synthase is a lot like a turbine in a hydraulic power plant. Instead of being turned by water, it's turned by the flow of H plus ions moving down the electrochemical gradient. As ATP synthase turns, it's catalyzed the addition of phosphate to ADP, capturing the energy from the proton gradient as ATP.
You have so many words for a student who got a pity remark. This process in which energy from a proton gradient is used to make ATP is called chemimosis. More broadly, chemimosis can refer to any process in which energy stored in a proton gradient is used to do work. Although chemimosis accounts for over 80% of ATP made during the glucose breakdown in a cellular respiration, it's not unique to cellular respiration. For instance, chemimosis is also provided in the light reactions of photosynthesis.
What would happen naman to energy stored to the proton gradient if it weren't used to synthesize ATP or do other cellular works?
Oh, so now you decided to ask an important question? Well, I hope at least you're learning. Eto na, gusto nyo eh. It will be released as heat, and interestingly enough, some type of cell deliberately use the proton gradient for heat generation rather than ATP synthesis. This might seem wasteful, but it's an important strategy for animals that need to keep warm.
Oh, di kayo na, siguro natakot lang kay Sir Rafi kaya nyo naisipan mag-lesson sa studio niya.
Kaya matatakot.
Excuse me? You have no respect to your teacher.
Right.
Mga kabataan nga naman ngayon.
For your information, you're still taking that quiz after this.
E di magta-transfer na lang kami.
Hindi mag-transfer ka.
Huwag kayong mag-away, Diyos ko! Wait lang po mga karapi tulfo. Magbabalik po ang